And here on the top of page 220, all we really do is we extend the same ideas to bases that just aren't E. You're going to see how similar they are. Really, there's only like one little thing you have to do, one little constant that we have to get in there. That was actually really there the whole time, but that constant ended up being 1, and so we don't include that in the rule when bases are E. But it does show up here when we're talking about exponential functions that aren't in base E, that are just base something else. Okay. And so when I call it base something else, so if y equals, just not e to the x, I don't know, I'll call it like a to the x. Could be anything. A for anything. C for constant would be fine. K would be fine. Those are pretty common. But A is good too. Here's dy dx. Okay. It used to be just e to the x, right? And the derivative of that was e to the x. So the only thing that we have to add in here is a constant that if the base were e, it would just be 1. But if the base is anything else than e, then this constant is not 1 and just kind of affects the slope of the derivative. And that constant is the ln of your base. Okay, the natural logarithm of a is a constant, right? It's e to what power gives me a. That's kind of what a logarithm is, right? It's the exponent that gives you the argument based on the base. And ln of e is 1, right? Because e to what power is e? Oh, okay, e to the first, right? So ln of a times a. And that constant, more often than not, is going to be irrational. There's really not much we'll be able to do with it, which is okay. It's just going to be part of our answer. It's just a constant sitting up front. Okay. If it was a little more than that, right, a to a function of x, so if that exponent is more than x, you're going to see it's going to be really, really close to e to the f of x, which was e to the f of x, right? Leave the original function the same and then multiply by the derivative of that exponent. We just need a little extra piece. All right, if you look back 4 or 5 pages or so, and you see how similar they are, it's really, really the same, right? We have the natural log of the base as a constant being multiplied through, times, leave the original function the same, a to the f of x, times f prime. And we'll definitely be using that one way more than we'll use this one, because usually if they're going to push us a little bit further, they don't just give us, 3 to the x or 5 to the x or 1/2 to the x. It'll be just a little bit more than that. Yay, there it is. Now we just practice. Now we'll just use it. I'm not going to bother with the 2 boxes right below here because it just says, hey, ln of e is 1 is really all that they're going to tell us when we do that. I want to get to the actual practice of it. Let's look down at the bottom of page 220 and get after it. Let's do top right first. Top left, sorry. F prime of x. And when I start thinking about my derivatives, I want to start, now that you have all these rules, now start looking at structure and deciding, okay, what am I looking at? What rule do I need to follow? This is exponential with a base that's not e. When my base is not e, I know I have 3 pieces to this puzzle, right? The natural log of the base, the original function itself, and then the derivative of the exponent, right? So here come my 3 pieces. The natural log of 4, so ln of 4, which is just some number, right? E to some power is 4. Some irrational number to some power is rational. I'm pretty sure that that's going to be irrational. That's okay. Times, leave the function alone, exactly as it's written, 4 to the x squared, times the derivative of just the exponents, which is 2. Again, this all comes back to like the limit with the difference quotient. They proved all this crazy stuff for us. Thankfully, we don't have to do that. We have a nice little rule that we can follow. And now we just have to put it in an order that we like, right? There's not a whole lot we can do here because it's all just being multiplied together. So we just gotta pick it's F prime. We just gotta pick an order that we like, and I think constants up front, transcendental stuff at the end, and then all the algebraic stuff in between. We just have two constants, the 2 and the ln of 4. And those cannot, like, there's not much we can do with that. Let's just put the nicer one first, I guess. 2 ln of 4. There's my constant. Algebraic stuff in between, so the x, I guess, sounds good. 2 ln of 4, x. And again, if you want like multiplication dots anywhere and everywhere, go for it. You don't need any of them. And then exponential stuff at the end, 4 to the x squared. A lot of people might put one right there to separate the algebraic stuff from the transcendental, right, from the exponentials. Some people might put them here, in between the constants and your variable. That's cool. That's really it. Not a whole lot more we can do with that. Nothing to simplify, nothing to factor, nothing to by the way. That's it. So it's really just about like being able to look back at the derivative rule and understanding what each piece is asking us to do, and just kind of deal with them separately and then put them in a halfway decent order. And this is not the kind of thing that I'm going to make you memorize. Okay, whenever we decide that we are ready to do something for real with all of this exponential and log rules, and whether it's base E or not, with the second half of chapter 3, you will have those rules. Okay, you will have them sitting in front of you each time. Okay. Don't go to the right yet. Let's go straight down to h of x. You try. Try h of x. See if you can find h prime of x right below our f of x there. 5 to the 2x minus 2. See if you can follow the rule. ln of the base, leave the function alone, multiply by the derivative of the x. You can see me writing my L's and even sometimes into the N's in script. I think that's good practice, but you certainly don't have to. You can write them not in cursive. What is that called? Not cursive writing. Print, thank you. Print your name. There it is. Man, I feel stupid. Okay. Damn right. That is for sure. I'd much rather grade 100 math tests than 100 English papers. Nightmare. Good for them, man. That's it. That's what mine looks like. Hopefully yours looks something like that. The order I'm not going to press too hard on. I don't care necessarily. If you have all the right factors and all the right spaces, I don't care what order you decide to write them in. I think that's probably the best one, though. Don't just leave it like the first step. Do something, right? Don't leave it in the first step in red. Don't leave it in the first step in blue. Mix it up, make it look a little bit nicer. Putting constants up front. Again, order of the constants don't matter. Put the stuff with the x. Sweet. All right, now we can go to g of x, top right. What's the big thing happening here, though? What's the big derivative process that we're going to try to follow to find g prime? Product rule. Okay, we're going to need the product rule first and foremost. Just as part of that, we're going to need to do a couple things to make it happen. Right? So u is going to be our x squared. V is going to be our 2 to the 2x. And then we can individually find du and dv. And it just depends on what they are. Now that we've got all these rules to follow, now we, I know what to do with trig. I know what to do with exponentials. I know what to do with polynomials, of course. And basically, that's it, right? Those are all the functions that we need. Now, all right, so dv, exponential, base isn't e, and the exponent is more than just x. I need all three pieces. Natural log, the function itself, the derivative. of the exponent. ln of 2 times 2 to the 2x times 2. I'm definitely going to be putting those multiplication dots along the way as I first apply the exponential rules for derivatives. And maybe you switch it around now. You say, okay, dv equals that, which equals, and then put stuff in a nice order. You can do that in your pre-work right now, or you can kind of wait until you get into the product rule and then put things in a nice order, because you're probably going to have to reorder it again anyway, because you're multiplying udv plus dv. Usually with the product rule, there's not a whole lot that we can do to simplify after. So let's see how this plays out. G prime of x, u, there's u, times dv. And there's no polynomials anywhere. It's one factor times something that has 3 factors. Everything's just connected by multiplication. I'll start reordering things now, I guess, but I don't really need to because I'm about to reorder it anyway when I simplify this. But hey, at least my dv is in a nice order there with the 2, then the ln of 2, then the 2x. But again, nothing to distribute here. We're just going to put things in a better order once we're done. And then ddu, dvu, and then clean it up. Now, you have some choice here, I think. For me, with product rule stuff, when there's not much I can do to combine stuff after, pulling out the common factor of 2x, 2 to the 2x, is fine. You can do that if you want, but I don't think it's going to get us very far. You certainly could. If you want to see what's in common, which I think is this 2 and that one of these x's with that one, and then this 2 to the 2x with that one, you certainly could. But I'm cool with us just saying, all right, I'm just going to reorder each of these. So look. Again, putting a multiplication dot anywhere you think is necessary, which is nowhere. It is not necessary anywhere, but it does, I think, nicely break apart some of these pieces. Here's what the factored version would look like in case you want to see it, in case you like it better. So I've got 2x, 2 to the 2x in common, which means what I've got left is ln of 2 x plus 1. I don't know that that looks any better. Maybe it does, though. Maybe you like that. Totally up to you. Start it as a product, finish it as a product. Okay, whatever you're comfortable with, whatever you feel like you think looks good. I probably, realistically, would have done it. Because I factor, and nothing is a like term for me to combine together. So why factor if it's not helping me simplify? There's good and bad to both. That's up to you, whichever one you want. Questions about any of these three? It's just, here's a rule, see if you can apply it, and then do some algebra. Go ahead, you try p of x. The thing that I will warn you about is that, yes, they've given us a negative exponent to start, which is great. I didn't have to worry about moving things around to do it. We just can't end it. Okay, just can't end it. And I will ask you to write it as a single rational function, just to practice that process. Looks like the product rule then. Make sure you got that going first. I'm going to hang on to the negative exponents all the way through until the end once I start moving things around. I'm not done yet, but I wanted to kind of bring it up to everybody to see what we think. Hopefully you get yourself to there, though. Negative 2 ln of 3x times 3 to the negative 2x plus 3 negative. I think we have a couple choices as to how to proceed to take care of the negative exponent. We could drop them both down separately, keeping the fractions apart, and then put them together. Like leaving the negative exponent as part of the first one, move it down. Second one, move it down, and then combine things together. Or factor it out now, and then you only have one fraction to deal with. And so while factoring up top with the one in blue really didn't do much for us, it didn't get us anywhere, I think factoring out this 3 to the negative 2x now, negative 2 ln of 3x plus 1, makes this a whole lot nicer because now single rational function 3 to the 2x on the bottom, negative 2 ln of 3x plus 1 on top. I like that a lot. That looks really good. Okay, definitely the trickiest one out of the 4. But either way, like during second period, we just fold the 3 to the 2x down to the bottom, and then, oh, look, my denominators are already the same. Cool, let's make one fraction out of it. It doesn't always work out quite so nicely like that. So this, like factoring out bases that have negative exponents is a really good way to create that single rational function in the first place. Because they ask us to do that so often. It's good. Good? All the way around, feeling pretty good? Sweet. So there is some more practice, but I'm going to save that for tomorrow. We're actually going to flip. We're going to go to the next page, 222. Okay, we'll save 221 for tomorrow. 222. Just a tiny little piece we got to add in. Okay, little piece that has to deal with log functions that just aren't base E. And you're going to see how similar it is to the natural log, which is good. So our 2 versions, again, I don't really need the first version because it happens so infrequently, but let's do it anyway. Log base anything, it is. Log base A of x. And so if that's our function, remember, it was a fraction when it was ln of x, so that's still going to be true here. We still have this fraction part. It's just that, ln of v was in there, but ln of v was just 1. And so multiplying through by ln of v didn't make much sense. It didn't change anything, but now we've got ln of a. That's going to be part of this. It's just on the bottom. Okay, this is 1 over ln of a times x. Okay. Because it's rational, the constant is actually like the reciprocal of ln of a, which is kind of cool that it works out. But again, just a constant of whatever that base is. That's probably not the version we're going to see very much. Certainly in this practice, we're probably going to be dealing more with log base a of just something more than just x. Right, a little f of x in there. So then our dy dx looks very, very similar to the one that we had last time. Right, derivative went up top, right? So f prime of x, still true. And on the bottom, it used to just be the original f of x, right? Whatever the inside function was. No logs with an x inside. We just need, again, that ln of a as a little, just kind of like affects the slope, the speed at which your derivative is changing is now affected by that 1 over ln of a. And instead of like separating and putting 1 over ln of a times, 1 over x or times f prime of x over f of x, we just make 1 for x. We just put the ln of a on the bottom. Make things a little bit easier. And that's it. Those are the two. Okay. And we'll use the second one, of course, way more frequently, probably all the time. But if they do give us an easy one, like log base 3 of x, cool. 1 over ln of 3 times x. Not too bad. Again, I'm going to skip these two down here. That's just kind of showing us that, hey, the ln of e is 1. That's all it's really kind of driving home for us. Let's see if we can do these 4 right here. And we'll probably stop right there, and then we'll talk plans the rest of the way. If this bothers you that there are no parentheses around the 4x, go ahead and draw those in so you can remind yourself that that inner function is 4x. It's just not necessary to do that, but it is good practice to make you feel a little bit better about where you're at. And we can go for it. F prime of x. Okay, so it's a log. It's just not base e. So I know I got a fractional. I know my derivative is going to be rational. I just have to think about what goes in which space. And by drawing those blue parentheses around the 4x, that gives me a sense of like what my f of x is, right? And what's supposed to go on top is the derivative of just that inside. Derivative of 4x is 4. Right, linear, so now on the bottom goes two different things, right? The ln of your base has nothing to do with the 4x, just the ln of 2, which is just a constant, but it's saying e to what power is 2? Well, I don't know, that, e to the ln of 2. That's what's going to give you 2. But times the original inside. They don't change a thing, just f of x, which in this case is 4. And because things are rational, it's really not into like distributing. We don't have like pluses and minuses. We're already sitting at a pretty nice version of this. We just want to try to look for anything. Maybe if there's some simplifying, we can do some rewriting. Can I make numbers smaller? Can I put things together? Do you see anything that maybe we could do? Yeah, let's take care of the 4s, right? They're all being multiplied, right? This is 4 times x and ln of 2. So away it goes. That looks good. So take a chance. Make things a little bit simpler. 1 over ln of 2 times x. Voila. Yep. Not too bad. Easy-ish rules to follow, which is nice, especially now that we're getting a little bit more comfortable with our derivatives. Let's do it. Let's do this one together. We'll go g of x this time. We'll go g prime of x and go across, Logarithm, cool. Derivative, going to be rational for sure. And so you see me do that every time. I just kind of like set up my fraction, and then I think about, okay, what's the top going to be? What's the bottom going to be? I deal with those things separately in my mind. I'll tell you what, if I didn't like prep for this lesson today, I would be looking back constantly at my rules. This is not something that I have memorized. Every year in calculus, when I get to here, I have to look back. I really do. I don't have them memorized from year to year. And that's okay. All right, cool. Up top, the derivative of the inside. Hopefully by now, this is almost coming to you really naturally. Derivative sine is cosine. And then on the bottom, ln to the base times the original function. And just like with f, we're looking for any way to write it simply, right? Dividing away things that are in common, finding ways to put logs together if we get lucky and something like that, trying to go from maybe like 2 trig functions down to 1, anything helps. It certainly is. Let's use it, right? Let's use cotangent. Now, the question is like, where does the cotangent go? And so I'm going to take some steps here that I don't think you need to write out unless you aren't sure where cotangent needs to end up. And it kind of goes back to the thing that I was saying before about if you wanted to pull like the constants out front and then like the functions separately, right? 1 over ln of 3 and then cosine of x over sine of x, that might give you a better view of kind of where cotangent ends up. So what's in blue there, I don't think you need to write if you can see that once we do kind of mentally or actually out in front, separate things out, that cotangent will end up on. And that's really what's happening with all the times you use a reciprocal identity or one of these, a quotient identity, to rewrite it in terms of secant, cosecant, tangent, or cotangent. It's going to go on top. Okay, it's going to go on top. Okay, challenge time for you, h of x and p of x. Go ahead. Here's my one hint for h of x. A little added set of parentheses inside there for cosine. Give those two a shot. We'll call it right there, and then we'll chat a little bit about plans for these next weeks. Cannot believe it. Next Saturday is May 1st. Yeah, right? Sorry. I'm going to scroll up so I have a little bit more space, and then we'll get after it. Simplify as much as you can, as best you can. First and foremost, though, this is a logarithm. So my derivative will look like that. Just need the chain rule to do. Hopefully you can get to there. But if you need the blue, like those blue steps that I showed you before, separating constants and functions, rewriting them and putting them back together, that's cool. It's a log, so it's rational. There's no base written there. What base is it? Common logarithm. Right? We have our natural logarithm, which is base e. Our common log is base 10. Ooh, but look at this. That's interesting. It's a log of an exponential. Inverses, logs and exponentials. I know they're different bases, but okay. So up top goes the derivative of the inside. And the derivative of the inside with that exponential is going to take those 3 pieces, right? This is looking back a couple pages, back to 220, and saying, no, I got to find the derivative of 2 to the 3x. because it's a base that's not e raised to a power that's more than just x, ln of the base, original function, derivative of the x. Okay. Bottom, ln of the base times the original. Cool. Leave it like that for a second. Let you kind of work through h of x and p of x. You haven't finished those up yet. We'll talk about what could happen. See anything we really like about p prime? Hold on.
I had a question.
Yeah.
Please.
Please. 3x, yes, thank you. 3x, thank you. Yeah. Yes, tangent 3x. Silly mistakes. Okay, now you're at 316. You know it. Common factor, get rid of it. And look what's left. ln of 2, a constant, times 3, another constant, over ln of 10, another constant. The slope of this function is constant. The slope of p of x, right, p prime of x, is 3 ln of 2 over 10, or ln of 10. This is not one of those properties of logs. I know it kind of looks like one. Property of logs is if you have two logs being subtracted, you can condense them to one and divide their arguments. These are just two separate logs being divided, nothing new. Okay? But let me ask you this. If your derivative is a constant, whatever that number is, what is the shape of your original function? What do you think? If your derivative is constant, what's that? Straight line. Log of 2 to the 3x is a straight line, with the slope being whatever that 3 ln of 2 over ln of 2. It's because the log and the exponential kind of catch. There we go. Nice. I'm good. I'm good with that practice to get us started today. We'll take tomorrow and kind of work through the ones that maybe we've skipped along the way. You'll see we'll get to some quotient rule there on 222. Those are some good ones for sure. But I'm happy with our calculus stuff for today. But I do want to talk with you for the next 10 or so minutes about what we think we should do to finish things up. As great as it is to think about that, we are in the home stretch here. So I have a couple of things that I want to talk about in no particular order. But I'll start with the one that's most pressing, this stuff here at the end of chapter 3. My plan, my thoughts were that tomorrow we would take a day kind of like we did yesterday. Learn the rule today, let's practice it again tomorrow, let's see what we got, and make sure we can handle some of the trickier ones, especially on a short Friday, right? Because we got late start Friday. We only have our 45-minute class, whatever it is, 40. We'll just take a practice day, but that'll be it, okay? Tomorrow, like I said as well, I will give you the rule for the derivative of inverses, nothing that will show up for us, but just so you have it, the tool in your calculus toolbox. But then we'll be done. So the question is, well, now what? Like, what do we do here at the end of chapter 3? So I wanted to throw some options at you and kind of get a sense for what you were thinking. And I think that there are two main options that we have to choose from. Option number one is to say, okay, we've done this second half of chapter 3 with just exponentials and logs. Option number one could be, let's take a quiz on just that stuff. Okay. Option number 2, and that quiz would be 1 day long in class, just on exponentials long. Option number 2 would be to say, okay, we finished chapter 3. We took a first half quiz. Let's take a full chapter 3 test that looks at everything: product rule, quotient rule, chain rule, and all the exponential stuff that happens over time. Option number 1, hands up, quiz only on second half. Yeah, okay. It is decided. Okay, cool. That's the plan. Now, what do we want to do for that quiz? 2 choices. Option number 1. Completely open note. In class, okay, completely open note, basically the stuff that, your Unit 3 guided notes. Where I design a quiz that is as hard, if not harder, than the most challenging practice ones that you'll do. Okay, so looking at, things like this for sure, if not harder. Or I post the derivative rules for them. I give you the rules, like let's put them up front here, but you don't get anything else besides a calculator. But the questions are more on par with the questions we've been doing, or maybe even just a little bit easier. Open note and challenging, very challenging. Or let's say closed note, I give you the rules, you don't have to memorize them. And more even, like more level. So option number 1, the hard one, open note. Option number 1. It is decided. Okay, there we go. All right. So now, when do we do? Monday or Tuesday? Monday or Tuesday?
Please, Tuesday.
Here's my question. Why Tuesday versus Monday? And if we choose Tuesday, then what are we doing here on Monday?
Because of prom.
That's tomorrow. Is prom this weekend?
Yes.
Saturday.
Yeah.
Yes.
If it's on Saturday.
So Mondays, like you have a whole day of rest after prom, and then you take a quiz that's fairly straightforward, and I give you the rules. The thing about like us taking a review day Monday is we're kind of doing that tomorrow. Like we're practicing it tomorrow. We basically will have had 2 practice/review days this week. I'm leaning more towards Monday. Let's just get it done. It's going to be straightforward. You'll be in good shape to do it, and then we can move on. Now, I want to still hear arguments 2 and 4 and opposed, because I'm not set on Monday yet. Yeah.
We see how tomorrow goes.
Absolutely. Let's make this decision together tomorrow on what we want to do. I'll tell you what, if the quiz is Tuesday and not Monday, it will be a little bit harder.
Monday.
Okay?
Monday.
Nice. There's kind of 3 levels to it. The Monday easiest version, Tuesday a little bit harder. And then we've already kind of knocked off the super challenging version. Okay, cool. All right, so that's done. That's chapter 3. Okay, that means that chapter 4 sounds like it's starting on Tuesday, okay, or Wednesday, depending on what we decide. So I will have guided notes for you for this last chapter. So folks at home, if this is something you want to pick up and not print yourself, let me know how you want to do that. I can either have copies ready for you probably by Monday, realistically not tomorrow, to come pick up, or you can have somebody pick them up for you. Okay, just let me know who you want me to give them to, and they can drop them off at your house. And chapter 4 is applications of derivatives. It's a really, really good one. It's going to be really important for anybody taking any calculus beyond this, whether it's A, B, or B, C, chapter 4 is super crucial to your success, especially those in BC, especially you in BC. So I want to like go all the way through the end of the year. I want to keep teaching. I want to give you as much calculus knowledge as I possibly can. But we still have one thing we have to do that isn't calculus. And it's the See You Succeed College Trig Final. For the large majority of us that actually signed up for that class, the size of that roster is more than half of the people in our class. So we're all going to take it. I looked at it, and it is easy. You are going to have a unit circle. You're going to have a calculator. You're going to have your trig cheat sheet available to you. And the questions are like, what's the cosine of pi over 3? What's the inverse sine of radical 2 over 2? Solve sine of theta plus 1 equals 2. Like, it is easy, okay? There is, however, there's one thing on there that we didn't have a chance to learn in January. And it's the stuff from chapter 9 we just did not get to. Okay, so I want to teach that to you. And so I have to talk to the other college trig teachers to figure out when they're giving their test. But I want to like teach you that last thing, and then like the very next day take that one. Or even like the same day. It's 14 multiple choice questions. It's not hard. It's not. I still want to give you a full class to do it, but we probably won't even need that, but I'll still give it. You know, we'll still take it over a period. I'm not going to let it count for a whole lot, but I still want it to help you, you know, so I'll put it in there, but probably not out of 100. I don't know. We'll see. Maybe I'll grade it first. It's one of those things where we really haven't, like, you know, we started trig in like November, December, like winter break, and then January, and we've been doing calculus for so long. Thankfully, I think it's pretty easy. It's like if cosine is positive and tangent is negative, what quadrant are you in? It's really not bad. But there are a couple things that I just want to make sure that I cover, and I want to like get the topics out to you, give you a chance to review if you want to do that. And but I think it's going to be really easy. We're all going to take it regardless of our See You Succeed choice or not, whether we took the class for credit or not. Let's all take it because maybe it'll help. And we'll kind of talk about that as we go. But I was thinking of doing that sooner rather than later. Like getting it done. Like let's just get it done, get it out of the way. So we can move on to chapter 4 and then just go calculus all the way through. And tentatively, I'm planning on like the final that we take to just be a chapter 4 test. It won't be a full semester of calculus kind of thing where we go all the way back to difference quotients and limits and graphs and stuff like that. It'll just be some chapter 4 stuff that we do during that time that we have, which I think is Friday the 21st, I think is our day after graduation. I think it goes 1st and 2nd on Wednesday, graduation day off Thursday, 3rd and 4th on Friday, weekend, 5th and 6th on Monday the 24th or whatever, and then 7th and 8th Tuesday. I think that's what our final schedule looks like. So it's really spread out, which is nice. Gives you lots of time to prepare for whatever you need to. Your APs will obviously be done by that point, whether you're taking those AP tests. Good luck to you. Lots of 5s coming at you, at least for us too. So I know you have to prepare for that, which is why I don't want us to stress out about a big, huge calculus final. I would rather just make it kind of like we'll just go as far as we can. We'll stop. We'll review for a little bit, and then we'll take a chapter 4 test during the finals. Something like that. That's kind of what I'm thinking. Does that work? Is that cool? I want it to be something that is worthwhile, but is not super stressful where you feel like you have to go all the way back to the beginning and relearn some of the things that we really don't need. Like you don't need the limit of the difference quotient. It's not something you need in calculus. We never use it once we learn these rules. So why test ourselves on things like that? So that's what I was thinking. I think that covers everything. Finishing up chapter 3. I would like to just do the quiz on Monday. And then maybe like stop the calculus briefly. And if we can, like take Tuesday, Wednesday, maybe, for me to teach some stuff, prep you a little bit, like have a kind of a review day. Like here are the topics. Let's practice like 2 weeks. Just make sure we got it. And then maybe see you succeed college trig thing Thursday. And then start chapter 4 Friday. Like maybe that's kind of like where I'm thinking maybe. Now that whole college trig see you succeed thing, that those 2 days, those 3 days, whatever we decide to do, I could put that anywhere, and I might have to move that plan around depending on when everybody else is taking. Okay. Well, I will get back to you on that. But you'll have plenty of notice. I will let you know certainly by tomorrow, if not Monday, if I want to do anything next week with this usage. And we don't have to do them back to back. I could teach you the thing, and then we could jump into calculus and then push it. But I think it would make the most sense to do like teach, review, final, like back to back to back, because then we can let the trig disappear for a while. I don't think that there's much trig, if any, besides like basic just derivative stuff in chapter 4. Applications of derivatives. And here's where we get into some trickier stuff. This is really where I think things pick up a little bit for the home stretch in terms of, we're not always going to do dy dx. There might be multiple variables in the problem. We start taking the derivative of y with respect to one of the variables, but we can't do them both, right? So maybe maybe looking at equations that aren't functions. Like let's see if we can find the derivative of a circle or an oval or a sphere. Start talking about the changes that happen. That's kind of my plan. So looking ahead to tomorrow, just bring this stuff back with you, and we'll have a little practice today for Exponentials 1. Adios. See ya. Thanks, everybody. Bye, everybody at home. See you all.
Thank you.
You're welcome. Have a good day.